In this video, we're going to try and understand why this is true. So for example, if you're trying to solve this, 7 equals 3 to the power of x, you're trying to solve x, the way you would do this is to log equally to both sides. You can use any log base whatever you want. So let's just use log a. So log equally to both sides, so that would be log base a of 7, and then you log base a of this thing here. And then for some reason, whenever you log one thing to the power of another thing, the power is able to come down. That's what this thing is saying. So the x is able to come down, and then the log thing stays the same. So that will then give you this, log base a of 7. So if you want to know x, you would, at the moment, you've got one block times another block, you would divide both sides by this block. So that would be log base a 7 divided by log base a of 3 equals x. Now we want to understand why is it that when you log one thing to the power of another thing, the x is able to come down. That's what this thing is saying. Whenever you log one thing to the power of another thing, the x is able to come down, and then the log block stays the same. That's this thing here. But to understand why this works, I need you to know this. So I'm expecting you to understand this and this. So what this is saying is that, for example, log base 2 of 2 to the power of 3, that equals, I'm expecting you to know this, that equals 3. In a way, these two, they cancel each other out, in a way. And then I'm expecting you to know this. So if you have like 2 log base 2 of 8, that is the number 8, because this is 3 here, 2 to the power of 3. Well, I'm expecting you to know these two. Now let's try and understand why this is true. So to understand why this is true, we want to know, if you look at this thing here, whenever you log one thing to the power of another thing, the x is able to come down. So really what we're trying to solve here is, whenever you log base whatever of 3 to the power of x, for some reason the x is able to come down. The x is able to come down. So basically we are trying to prove this. So let's try and understand how to get from here to here. So if we start out with this, how do we get from here to here? That's what we're trying to understand. So hang on, we want to get from here, log base 3 to the power of x, and somehow get to here. That's what we want to do. So the trick is to rewrite this 3 as rewrite that 3 as a rewrite that 3 as a to the power of log base a of 3. You see that there is the number 3, just like this. So so you can write any number. For example, the number 10, the number 13, you can always write the number 13 as whatever a log base a of 13. That is the number 13. So if you want to write the number 3, you can always write the number 3 as this. You can rewrite as a number log base of the same thing, 3. That is the number 3, by the way. So this here we know is the number 3 because of this. We can put that into the 3. So because we know this is the number 3, we can put it into that 3. So that would then become log base a of a log base a of 3. So this here is the number 3 to the power of x, to the power of x, to the power of x. So we are just putting this into the number 3. Now remember, x to the power of a is x to the power of a to the power of b. That's the same as you multiplying these two together. That's the same as you multiplying this thing with that x. So that would be the same as log base a, and then you multiply these two things together. Don't forget, this is just one block. So that would be x log base a of the number 3. So now you can see that whenever these two are the same, they in a way they cancel each other out, leaving you with just the index here, leaving you with x log base whatever of that 3. So that's how we got to that thing earlier. Okay.